acute radiation damage is what happens when something is exposed to a large amount of radiation in a short period of time. Main sources of acute radiation damage are going to be nuclear bombs and exposed nuclear reactor cores. This is not something that the average person needs to worry about, right? But when this happens, a large number of cells will die. And the ones that are most vulnerable are those in the immune system and the intestinal lining, because here the cells are rapidly dividing. So symptoms of acute radiation poisoning are going to include a weakened immune system and the inability to absorb nutrients. So you can recover from a mild case, but death is almost inevitable in more extreme cases. And the death is not from the radiation itself necessarily, but from infection that sets in afterwards, because your immune system has been destroyed, and so you can't fight off the normal germs that just give you a bad time. They don't actually kill you. Now they're going to kill you. So lower doses of radiation over long periods of time, or chronic exposure, can increase the risk of cancer. So radiation can damage your DNA. The DNA is the molecules in your cells that carry instructions for cell growth and replication. You cause defects in DNA, and then the cells reproduce with incorrect instructions. And some of these will start to grow out of control, and that's what cancer is. It's basically abnormal cells growing out of control. This damage often kills these cells, but sometimes they can just go rogue and become cancerous. Cancer risk increases with increasing radiation exposure, but we cannot determine the exact threshold at which your risk is increased. Radiation exposure can cause genetic defects in future generation. If the DNA in eggs or sperm are damaged, then the offspring could have genetic abnormalities. What's really interesting is genetic defects like these have been observed in laboratory animals, but they have not been verified in humans. One of the issues, of course, is who's going to volunteer to have radiation exposure to see if their children have defects? Nobody, right? But even studies of Hiroshima survivors who were exposed to a tremendous amount of radiation, a lot of them died, but some of them lived, still no evidence for genetic defects in humans as a result of radiation. But we know that it is possible because it does happen in animals. Any questions? How do we measure radiation exposure? This is actually a little bit difficult. Radiation exposure can be measured as the number of decay events in a particular amount of time. So the Curie is a unit that does this. The Curie is 3.7 times 10 to the 10th decay events per second. But this does not accurately measure how much biological tissue damage may occur, as different types of radiation produce different effects. Right? We talked about alpha, beta, and gamma radiation as being a semi-truck and a car and a motorcycle, right? And so they have different degrees of ionizing power that, when they smash into things, how much damage do they do? That is different. And they also have different penetrating power. Alpha particles can get stopped by, a piece of paper, right? So outside your body, they do very little damage. But if you're inhaling them or ingesting them, then they can do a lot of damage. So the Curie is just measuring decay events per second. So a better way is to look at the radiation dose, which is the amount of energy that's actually absorbed by the body. 2 units for this are the gray and the rad. A gray is 1 joule per kilogram of body tissue. A rad is basically a centigrade, 0.01 joules per kilogram body tissue. And RAD stands for radiation absorbed dose. This again isn't all that useful because it doesn't account for the differing amounts of damage. Gamma rays result in low ionization density, alpha rays in high ionization densities because of the differences in their ionizing power. So another way to measure this is using a biological effectiveness factor, say that 3 times fast, or RBE, relative biological effectiveness. And so that's a correction factor. You take the dose in rads and you multiply it by this factor to get the dose in REMS. REM stands for Röntgen Equivalent Man. Röntgen is another unit of radioactivity. So this is going to give you a better estimate of, well, how much damage is this actually going to cause? So the RBE for alpha radiation is a lot higher than for gamma radiation. This is just an interesting table showing different sources of radiation. The first section is natural radiation. Ride on an airplane for 5 hours. You're going to get exposed to radiation because you're higher up in the atmosphere. If you stay on Earth, you're still going to be exposed to cosmic radiation. So the jet plane ride is 2.5 millirems per trip, roughly 5 hours. Cosmic radiation, staying on the ground, 27 millirems per year, right? Is this a reason not to fly? No, it isn't. Terrestrial radiation. Okay, so, we've got cosmic radiation coming in, but we also have radiation coming up at us from the ground, 28 millirems per year. So both of those you could technically shield yourself from, but then you also have natural radionuclides in your body. Yeah, can't get away from those. 35 millirems per year. And the most significant source of natural radiation exposure is radon gas. So we don't have much trouble with that here in California because nobody has basements, right? In the Midwest, most houses have a basement. This is another level down under the ground, right, for various reasons. And some of those regions are naturally have a lot of radon gas in the soil. So the radon gas can get into your basement. And so you go spend time in your basement and you're breathing in radon gas. And so this can be harmful and can cause increased cancer risks. So there's a whole industry in radon abatement. So they'll go in and test your basement, and then there's different things they can do to keep the radon from coming into your basement. That's one of those niche careers, right, that you didn't even know about. There's so many of them. You can also get exposed to radiation through medical procedures. Many of these are pretty routine: chest x-rays, dental x-rays, mammograms. These are things that people normally have maybe, once or twice a year. So here we've got a chest x-ray, 8 millirems. Dental x-rays, 30 millirems, or for 2 bite wings, 80 millirems. A mammogram, 138 millirems. But, these are not significantly higher than what you're getting just from natural radiation. The rest of these are going to be higher doses of radiation, but these are going to be specialized tests, right? Consumer products also have some radiation. Luminous watches, those used to have radium on them. Really bad idea. They didn't know any better. Now they've got protium and PM-147. But so I would not go with the glow-in-the-dark watch Personally, I go with one that maybe has a little light. You push a button and the light comes on, or just, digital, right? Or what's wrong with the cell phone? Cell phone's great. Interesting, tobacco products. So someone who smokes 30 cigarettes a day is being exposed to 16,000 millirems of radiation per year. That's a lot more, right? That's like 16 CT scans. It's crazy, right? And that radiation comes from a number of different sources. Some of it is taken up by the tobacco plant from the ground. Some of it is from things that are just on the tobacco leaves. But what makes this really dangerous is that you're inhaling it into your lungs. So you're bringing it inside your body. So there's just, another good reason to not smoke. Like you need another one, but. So it takes a lot more than average natural radiation. This is another typo. This has nothing to do with female deer. The dose, natural radiation dose, from natural radiation or from a diagnostic procedure. The previous doses were in millirems. Here we're looking at rems, so 1,000 times larger unit. So 20 to 100 rems may cause decreased white blood cell count, possible increase in cancer risk. 100 to 400 radiation sickness, vomiting, diarrhea, skin lesions, increase in cancer risk. So for someone having radiation therapy for cancer, they're probably going to be down in this first range here. I have a friend who had radiation treatment for cancer, and she was just wiped out. I mean, it didn't cause all of the horrible effects of chemotherapy, vomiting and stuff, but she was just wiped out because, it really stresses out your body. You get up to 500, 1,000, 2,000. 2,000 rems is generally going to cause death within hours.